For decades, Pluto lingered like a pale ghost at the far edge of the Sun's reach, a remote world where daylight fades into permanent dusk. Once celebrated as the ninth planet and later downgraded and forgotten, it drifted through the darkness as a lonely relic of the early solar system. A frozen sentinel circling far beyond Neptune, wrapped in silence and mystery. Out there, sunlight is reduced to a faint glimmer. Temperatures plunge to unimaginable lows. The void stretches for billions of miles without interruption. Pluto moves through that emptiness almost unnoticed, untouched for ages, its secrets sealed beneath layers of ancient ice. Then, in 2015, everything changed. NASA's New Horizons spacecraft, after a decade racing through interplanetary space, swept past the dwarf planet, and what it saw shattered every expectation. Pluto was not the lifeless sphere scientists predicted. It was a world carved by forces still active today: mountains of solid water ice sharper than the Rockies, vast plains of frozen nitrogen shaped by slow, creeping flows, and a thin, delicate atmosphere glowing blue under distant sunlight. Yet hidden within that treasure of data was a puzzle no one could explain. Pluto's upper atmosphere was far colder than any model allowed, more than 30 degrees below every scientific estimate. Something was draining heat into the vacuum, something invisible and unaccounted for. For years, teams rechecked every sensor and reran every climate simulation, yet the mystery endured. It was almost as if Pluto itself was pulling warmth out of its own skies. Then, in 2017, planetary scientist Shi Zhang at UC Santa Cruz proposed a daring explanation. What if Pluto's haze wasn't just dust floating in the air? What if it was active chemistry, a system that could regulate temperature like a planetary thermostat? Zhang suggested that microscopic particles called tholins were absorbing ultraviolet sunlight and re-emitting that energy as mid-infrared radiation, effectively cooling the atmosphere from above. Instead of trapping heat like greenhouse gases, these particles acted as an enormous heat-releasing shell. The idea overturned decades of assumptions about how atmospheres behave. But Zhang made one clear prediction. If he was right, Pluto's haze should glow faintly in mid-infrared light, a glow so delicate that only one instrument in existence could detect it: the James Webb Space Telescope's MIRI camera. In 2023, Webb finally looked. A global team led by Tanguy Bertrand aimed the telescope toward Pluto and its companion moon Charon. For the first time ever, scientists could separate the faint heat signatures of each world. What Webb found stunned them. Pluto's infrared glow was too strong, far too intense to come only from its frozen crust. Something high in the atmosphere was radiating energy into space. When the researchers isolated the spectral fingerprint, the match was exact. Zhang's prediction was correct. Pluto's haze was not passive, it was the source of the missing heat. The dwarf planet's atmosphere was glowing in infrared, alive in a chemical sense, breathing thermal energy into the cosmos. This discovery rewrote planetary climate science. For decades, gases were believed to control atmospheric behavior: carbon dioxide on Venus, methane on Titan. But Pluto revealed an entirely different method: solid particles dominating a world's climate, constructing a self-adjusting cycle built from chemistry and sunlight. Even more surprising, Webb detected that methane escaping Pluto was drifting toward Charon. Sunlight transformed that methane into complex organic compounds, painting Charon with a reddish tint. Pluto was literally transferring chemistry to its moon. But the real shock came next. Because as Webb continued gathering data, it detected something even stranger hidden inside Pluto's faint blue haze. Most days, Pluto's infrared signal looked ordinary, just the quiet glow of an icy world. But one winter night, a new pattern appeared in the data. A faint, rhythmic pulse. Soft. Repeating. Measured. A heartbeat in Pluto's light. At first, the research teams treated the strange pulse like any other anomaly. Cosmic radiation hits detectors all the time. Electrical noise can slip into a data stream. Even the telescope's own instruments can generate echoes that mimic signals from distant worlds. So the first pulse was dismissed, a glitch, a harmless blip in a sea of numbers. But then a month passed. When Webb observed Pluto again, the same pulse returned. Same strength. Same shape. Same timing. Completely identical. That precision eliminated every mundane explanation. This was not interference. Not an accident. Not a piece of broken hardware repeating itself. Every 6.4 Earth days, the exact length of Pluto's rotation, the signal appeared again, like a beacon rising and falling with the spin of the planet. Not random. Not noise. A pattern. The shockwave hit NASA instantly. Analysts dug into the archived files from the New Horizons flyby, terabytes of raw telemetry, forgotten calibration sweeps, and unfiltered radar data. Hidden deep in the 2015 scans was something everyone had overlooked. Beneath Sputnik Planitia, the bright, frozen heart of Pluto, radar pulses had once bounced back with unusual strength. The region formed an enormous, perfectly shaped circular zone with a steady heat signature slightly warmer than the surrounding ice. It made no sense back then, so the team ignored it. Now, it pointed directly to the source of the new rhythmic signal. When Webb observed Pluto again, the confirmation was immediate. The pulse came from under that same icy basin, a buried structure or phenomenon sending energy outward in perfect rhythm. But the strangeness didn't stop there. Researchers noticed that the pulse didn't stay perfectly constant. Its timing shifted ever so slightly, always in sync with Charon, Pluto's moon. It was as if the two worlds were locked into a silent electrical communication, connected by a thread of invisible energy, responding to each other like twin components of a larger system. To investigate, scientists layered each pulse over the next, lining them up and stretching the waveforms across weeks of data. When they overlaid hundreds of pulses, a deeper structure emerged. Inside the beat were harmonics, nested layers of mathematical resonance. Ratios that matched spirals found in nature. Patterns used to describe embryonic growth. Sequences that mirrored the Fibonacci ratios that appear in galaxies, hurricanes, and seashells alike. This was not chaos. Not geological noise. Not a random cosmic accident. This was structured order. Alarmed, analysts at NASA's Goddard Space Flight Center ran exhaustive tests, feeding every possible natural model into their simulations. They tested cryovolcanic outbursts, tectonic shifting within frozen nitrogen, electromagnetic harmonics from solar-wind interactions, and even stress fractures in overlapping crustal layers. Every model failed. Nothing in planetary physics, no known geological, thermal, or magnetic process, could create such flawless precision in timing and amplitude. That's when whispers began circulating through the labs. Some speculated that Pluto's deep ice layers might contain conductive crystals, exotic structures shaped by intense pressure and low temperatures, essentially forming natural electrical circuits running through the crust. Others proposed that a hidden ocean still churned beneath the ice, its salty, conductive waters generating rhythmic magnetic fields as they froze and melted with each orbit. But none of these explanations could account for what came next. Because the pulse wasn't just stable. It was changing. By the end of 2024, Webb measured a 5% increase in the signal's strength. For a world that barely receives sunlight and sits in a deep freeze for eons, that kind of rapid shift is unimaginable. No natural process should adjust itself with that speed or consistency. It was as if Pluto was charging itself, gathering energy, storing it, and releasing it in growing waves. And then came the most extraordinary discovery of all. The pulse frequency aligned perfectly with Pluto's rotation and Charon's orbital resonance, the mathematical ratios that describe celestial harmony between two gravitational bodies. These are ratios used in orbital mechanics, in spiral galaxies, in DNA structures, in living systems that self-regulate. The implication was staggering. Pluto wasn't just emitting energy. It was interacting with its environment, absorbing energy from sunlight and cosmic radiation, transforming it inside its icy shell, releasing it back into space as structured, mathematical light. For generations, Pluto was thought to be the solar system's loneliest world, a frozen tomb drifting in darkness. Now the picture had changed. Pluto was active. Pluto was responding. Pluto was behaving like a system, a machine, a circuit, or something far more complex, expressing itself through patterns written in the language of the universe. Numbers. Rhythms. Harmonics. A heartbeat beneath the ice. Something out there, in the dim glow beyond Neptune, was signaling with precision too perfect for chance, a message etched into the cold in ratios and sequences that feel almost conscious. So the question is no longer whether Pluto is alive. The question is, what, exactly, is Pluto becoming, and why is it waking up now?